We're going to continue our talk about domain and range. And what we want to do here is determining the domain given an equation. So that's going to be our goal. Here's the key to determining the domain, which sometimes is not easy to do. Declare first what is allowed in the range. Now you do have to declare what's also allowed in the domain, but this is often overlooked, so I'm kind of focusing on this. To determine the domain of a function, you must declare what's allowed for the range. And here's an easy example. At some point in your life, you didn't know what a negative number was. It held no meaning, and you were not informed of such a concept, right? So in elementary school, you were asked to practice subtraction, such as some number minus 7 equals another number, right? If you're not allowing for negative numbers, in other words, cannot be negative. This output is not negative. And fractions answers. What is the domain of this function? So what can you allow here if you're not, no fractions answers, and this cannot be negative. So what we need is, well, if it cannot be negative, that's one thing we can talk about, is that this must be greater than or equal to a 0, right? In other words, this whole thing represents the output, and we need it to be greater than 0. Now, if that's the case, when I solve for this, I get that my unknown has to be greater than 7. Furthermore, since we're not allowing fractions, we're going to say the following. What is the domain? The domain is a positive integer equal to or greater than 0. Sorry, that's 7. And that's it. That's my entire domain. So if I were to describe a little better, it's going to be integer. And let's keep x is greater than or equal to 7, or using, I'm going to use interval notation. So here I'm just declaring that this has to be an integer. It cannot be just any number. It cannot be a real number. And I can start at 7, and I go to infinity. And there's my domain. So in this class, the range will consist of what? Real numbers. So, and the domain of our function must satisfy the following. The domain will consist of real numbers. So again, we have real numbers for domain, real numbers for domain, such that the output of a function produces a, and you guessed it, real number. Now, I don't know if you recall what a real number is. And this is the criteria for domain and math 111. What is a real number, by the way? I think just about anything you can think of is a real number, with the exception of one item. So for example, 3 is a real number. Pi is a real number. Square root 7 is a real number. 3/2 is a real number. Okay. So basically our entire number line consists of real numbers. When you graph and you had a number line, here's the x-axis, the real number fills this entire axis, leaving no gaps. So basically everything you think of is a real number, with one exception. depending on your background. Now let's look at this particular example. Example 2. What is domain of this function, 5x plus 9? And here's how you do this. Later, you're going to just memorize what the domain of this, because you'll recognize also what this type of equation this is. But let's think it through for a second. What is happening here? I am multiplying two numbers. Okay. And the question I have for you is, if you're using two numbers, if I do real number times real number, for example, I'm just looking at these two together, what is the outcome? Have you ever multiplied two numbers that are real and produced something that's not a real number? I mean, think about it. And the answer is no. Wait a minute, every time I multiply two real numbers, the answer is some other real number. So there's no problem here. I can pick any two real numbers, multiply them, and I get a real number. And what's the next operation? I'm also adding. Oh, and also just in case this crossed your mind, remember these are negative numbers, so negative numbers are also real. I'm also adding, so the question becomes this. If I have a real number and add it to another real number, what is the result? Again, have been adding numbers all your life and you've never had a problem. Every time you add two numbers, you come out with another number. Whether you classify it, in your mind, you see it as real or not, that's what the result is. So this is also a real number. So what is domain of this thing? Well, I can choose anything. My biggest domain that I can have in Math 111 consists of real numbers. That is the biggest thing I can have. So it looks like I can use any real number and it will produce a real number back out when I produce, multiply here and add. So the answer is going to be the domain, back on the over here, domain is, and I'll use interval notation to describe it, is everything negative infinity. In other words, all real numbers. Nothing is excluded. Okay. Let's look at another one. What is the domain of this function? I hope you recognize that this is linear. As a matter of fact, if I go back to this question, this is a linear equation. I'm multiplying some constant times a variable and adding some other constants. And that's what this is describing. By the way, how do I know this is a linear equation with this funky notation? Because, I do have an m and a b, but how am I supposed to read the m and the b? Well, the function notation lets you know that the only variable here is x, and then that must mean that m and b are constants. They're unknown at the moment, or not being used, not being declared, but they're constants. So this is the same thing as the previous example, example 2. So domain is again all real numbers. Fun fact, sometimes the notation for real numbers is this. You might see this in time from book to books. The notation for real number set, all real numbers, is this R. Yes, and it looks like this with these two double bars. It's not just a regular R. It has this double little line here, this fancy R. So this implies real number set. So this is a symbol for real number set. Okay,